We welcome you back to the educational webinar series brought to you by WeatherWorks. My name is Nathan Wiles, lead meteorologist and assistant marketing director of the company. Today we will be discussing the topic of ice and examining a few ways ice can form to better prepare you for the slippery road ahead. Our presenter today is WeatherWorks' own senior forensic meteorologist, Tommy Else. Tommy has been with the company for 24 years and has served not only as a senior forecaster for the New England states, but he continues to perform as a leader in the forensics department at WeatherWorks, preparing site-specific past weather reports and providing weather expert testimony as an accredited AMS Certified Consulting Meteorologist. Tommy, the floor is yours.
Well, thank you, Nate, and good morning, everyone. As Nate just talked about, I am the senior forensic meteorologist for WeatherWorks. And actually, I started at WeatherWorks in 1996 as an intern meteorologist. And I graduated from Kean University in 1997 with a degree in meteorology and minor in math. And that's when WeatherWorks hired me full-time as a meteorologist. And some of the responsibilities I've had over the last 24 years is forecasting and consultation for the Mid-Atlantic and New England states. Also, I extended out into the West as well. So that various research and forecasting and preparation and consultation has given me extensive knowledge in the snow and ice industry. And besides forecasting as well, I also do something called forensic meteorology. And we're going to get into that in a little bit. But a little bit more of my background, again, as Nate alluded to, I'm the senior forensic meteorologist. I'm also a certified consulting meteorologist by the American Meteorological Society and also by the Snow and Ice Management Association. I'm an advanced snow manager certificate holder as well. I've been doing this for over 24 years. The other aspect of forecasting I have done in meteorology is what's called forensic meteorology. And in case no one ever heard of that, forensic meteorology is a process of reconstructing the weather for a particular date, time, and location. Now, meteorologists as a whole get pretty much a bad reputation. They say, weather is so unpredictable, you guys get paid to be wrong. Well, the one thing I like about forensic meteorology is it already happened. Okay, the social media, no weather hype with this. The event already occurred, and it is what it is. And what happens in forensic meteorology is all the weather data is archived. That includes radar, satellite images, National Weather Service zone forecasts, watches, warnings, advisories, all the snowfall totals, all the observations. Everything is archived at what's called the National Center for Environmental Information in North Carolina. And that data is archived, and it's easily extractable to anyone. In fact, anyone can get that data archived and access it, and that's what we do. And some of the reports I work on are consisting of slip and falls on snow or ice. I've even done slip and falls inside a business on a wet floor. Someone drags in some moisture, wind damage, floods, lighting cases, sunrise, sunset, sun glare. Unfortunately, I've done some fatalities with auto accidents, weight of snow on a roof, lightning strikes, excessive heat or cold. Since 1995, WeatherWorks has worked on thousands of cases, and I've even testified in court as a weather expert. But most of the cases right now I work on, I'll say about 75% deal with snow or ice. Now, part of this presentation, I want to talk to you about how snow or ice forms, the different types of snow or ice, what you can do to alleviate conditions and prevent it from happening. And then also, how do you protect yourself? How do you know when snow or ice is going to be in the forecast, or there's a refreeze, an ice watch? How do you get consultation for that? Well, there's two different types we'll talk about. One's free from the National Weather Service. And if you don't want that responsibility of checking for yourself, then you can go a little bit more, go with a paid service where you can get consultation on and pay for a private forecasting company, which will do all the background information for you. Okay, so let's start getting into the presentation on the different ways ice can form. And I'm going to talk about several different ways. The first way is rain that freezes on contact with a surface where the temperature is 32 degrees or colder. In meteorology, we call this freezing rain. And sometimes, I've been talking to a client, it's 27 degrees, and they're like, hey, it's raining out. No, it's what's called freezing rain. It looks like rain, but the difference is once that rain hits that temperature surface, 32 degrees or colder, it freezes into what we call clear or black ice. Okay. The second type is accumulating snow and sleet. Okay, snow is made up of ice crystals. Sleet is a frozen rain droplet. Okay, when that's on the ground, it's slippery if someone steps on it. Now, after a snowstorm happens, you get residual snow cover that's on parking lots, walkways. Okay, when that snow cover becomes disturbed and stepped on by pedestrian foot traffic or motor vehicles, you compact that snow. When you compact snow, it's similar to you making a snowball. It goes directly into ice and becomes a slip and fall hazard. All right. The other way that you have to watch out for ice forming is what's called runoff water on ground surfaces. Let's say after a big snowstorm happens, the sun comes out. Okay, temperature goes above freezing. What's happening? Well, a combination of the sunshine and the above freezing temperatures will result in that snow to melt and generate runoff snow melt water. Now we got a problem because after sunset, no longer with the sun applying heat, temperature goes below freezing. If you don't have a de-icer, such as rock salt, calcium chloride, magnesium chloride on those surfaces, that untreated runoff water will go directly into ice and results in a slip and fall hazard. Okay, now let's talk about some of the ways, or actually we just talked about the ways different ice can form, but let's take a look at some different types of ice, because I had working on a couple of cases, and one of the first things I asked the attorney is when I get a slip and fall case is, okay, what did the plaintiff or person alleging that they slipped and fall, how did they describe the ice? Did they say it was clear? Was it transparent? Or did they say, no, it was opaque, it was dirty, grayish color, or any different type of explanation helps me develop my conclusions and see how that ice formed in the first place, okay? And the first one I'm going to talk about is what we call black ice. Okay, and you can see in this picture here, all right, this is a perfect example of black ice in a parking lot next to adjacent vehicles. And if you look real closely, you can see like a little glare to this. But the reason why people call it black ice is because it forms mainly on, and you see it on asphalt surfaces, parking lots, roadways. It's transparent, it's thin, it's see-through. It almost looks like it's wet. But you step on that, you're going to slip and fall quickly, okay? And two ways that this type of ice can form. One, from freezing rain, which is rain that freezes on contact. Or two, runoff snowmelt water, okay? When the temperature goes below freezing, it's going to refreeze into clear ice unless there's a de-icer on the type of sidewalk there or the parking lot surface. Now, we talked about the black ice, okay? Does black ice always form on a parking lot surface or a roadway? No. You can get black ice on a concrete walkway, a sidewalk, a brick paver, etc. Let's take a look at our next example, okay? This is also an example of black ice, but again, it doesn't have to form on a roadway or parking lot surface. This is a case I did where I was working for the plaintiff, and you can see her right now sitting on the walkway. And just a quick glance at this real quick, and you're going to say, yeah, everything looks wet, but this was during a freezing rain event. And as that person traversed from the parking lot surface onto that walkway, she immediately slipped and fell. Now, the good thing about this case is surveillance video caught it, and we actually zoomed in. And when you zoom in, you can actually see a little bit of grayish, whitish tint to that ice on the sidewalk, okay? This is the same reason why when you make ice cubes at home, you take a look at the ice cubes and they're not perfectly clear. They're whitish in color, and that comes from the impurities in the water and also gases trapped within the ice. So that walkway you're looking at right now, the little patches of white and gray, that's from impurities in the water and also from air that's getting trapped in there, and which gives that a little bit color. But I wanted to show you this because you don't always have to have black ice on a roadway or parking lot surface. Again, it can happen on a walkway. It could happen on a brick paver, a sidewalk, any type of surface, okay? Basically what you're gonna look for is it's gonna be clear, it's going to be transparent, it's going to be thin, and it's a very dangerous slip and fall hazard. Now, what do you do in situations like this? Well, if it's a freezing rain event, the problem with freezing rain is some people say, you know what, I'll just put down, I'll pre-treat. And what pre-treatment means is you put down a type of de-icer before the event begins. But the problem with freezing rain If it's an ongoing freezing rain event, that's not going to work. It will hold you initially, but as that freezing rain continues to fall, what happens is the de-icer becomes diluted. And when a de-icer becomes diluted, it's not as effective. So you continuously have to reapply. All right. Other ways that black ice can form, again, with runoff water on snow that refreezes into ice as the temperature drops. You could, before that water freezes into ice, you could put down de-icer such as rock salt, calcium chloride. What that does is it turns to a brine solution and lowers the freezing point of water. Now, if the ice is already formed, okay, then you're going to put down, again, depending on the type of surface. If it's a parking lot surface, you're going to put down rock salt. But if it's a walkway or brick paver sidewalk, you don't want to use rock salt necessarily because it's pretty corrosive. This is where they go to more stronger substances and more environmentally friendly, calcium chloride, magnesium chloride, etc. You put that de-icer down onto that ice, then you get the combination of sunshine, moisture from the air. That de-icer, it extracts all that and begins to break the bond of the ice. It doesn't melt the ice, it breaks the bond of the ice, which then begins to allow it to melt, and it turns into a brine solution. And you're able to, once it becomes a brine solution, it lowers the freezing point of water. So, a lot of misconception is that, the de-icer melts the ice. It doesn't. It's technically breaks the molecular structure and bond, which allows it to go from ice into a liquid substance. All right, now let's get on to this second type of ice that we normally see, and that is what's called opaque ice or old snow and ice on a walkway. In this case here, I worked on a slip and fall. A person walked out of a restaurant and slipped and fell on this sidewalk. And if you take a look at this sidewalk, this was a shoddy job done by the snow plowing contractor, the landscaper, the property manager, or the grounds crew. And what happened was, I think it snowed and they left it there. And you could see all the pedestrian foot traffic there, the footprints. Again, what happens when you step on snow? It compacts, it forms into ice. You come across a situation like this, okay, you can immediately tell it's an old event because the snow is white, it's opaque in color, okay? When you come across a situation like this, ladies and gentlemen, you might not even be able to put down a de-icer such as calcium chloride or magnesium chloride and burn and penetrate all the way to the surface with this. You need something that's going to break the bond, okay? That's where a de-icer comes in. But if it's thick enough where there's a lot of residual, you're going to probably have to use an ice pick to break that ice up, okay? Get it out of there, then put down the de-icer to break that bond from that walkway and start to have it turn into more of a liquid and then a brine solution. All right. Now here's another example. Okay, you don't just have it on walkways. Okay, this is a picture from Shutterstock that I took off the internet. Okay, nice sunny winter day. The angle of the sun is very low in the sky. You can see it. Look at this compacted snow on the roadway. See, a snow plow can only get down to a certain level on the roadway or parking lot surface. Okay, especially when the snow becomes bonded to the surface. So the snowplow can only get so much. This is where the de-icer comes in, such as rock salt or calcium chloride. It breaks that bond. But when you have pedestrians and vehicular traffic traveling on that snow, look at the compacts, okay? And you can also see the little glare of the ice and snow. It's frozen solid. It's very slippery. You see something like this, you're going to have to get out there. The plow is not going to do it. You're going to have to put a de-icer down, let the sunlight and those temperatures make the de-icer more effective, begins to break that bond, and it will gradually loosen that up, turn it to more of a slushy area or even some runoff water, and then you can go and clear that out. Okay, well, we just talked about the two different types of ice, clear ice or black ice, and then you have opaque snow and ice left over from a storm. All right, well, how do you protect yourself? Okay, and one of the first ways I'm going to talk to you about is the freeway, and that's by the National Weather Service. Okay. If anyone has access to the internet or your cell phone, you can go to the main address, which you'll see in the upper left-hand corner here, called weather.gov. Okay, it's a free service offered by the National Weather Service. The National Weather Service is under the Department of Commerce. All right, there are numerous National Weather Service forecast offices across the United States. Each one, okay, has a job in a certain geographical region they have to cover. Okay, Now, if let's say you're talking, we'll just use a town example in New Jersey, Trenton, you would go into the upper left-hand corner here, type in Trenton, New Jersey, hit go. Okay. And what that will do is it'll bring you to the local National Weather Service forecast office that covers Trenton, New Jersey. More importantly, you'll also get a very detailed forecast out to the next 7 days, which will consist of graphics and text. And if there's any watches, warnings, advisories, or special weather statements in effect, you'll see those as well. Okay. And I'm just going to give you an example. So if I typed in Trenton, New Jersey during January 22nd, 2016, you'll see on the left-hand side here, this is an example of a zone forecast, okay? And it will tell you, sunshine this morning, then becoming cloudy, gives you the temperature, tells you snow developing after midnight, 1 to 3 inches, okay? And then you'll notice, too, it says blizzard warning in effect. Now, if you look to the right-hand side, okay, this is the actual blizzard warning that's in effect for Mercer County, which is where Trenton's located. And it will tell you heavy snow, gusty winds, blowing snow, snow accumulation 10 to 14 inches, when the snow is expected to start, when it's going to end. Also talks about, the wind, the gusty winds, the blowing snow and drifting snow. All right. Another product they issue is what's called a special weather statement. Okay. If you look at this special weather statement here, these are issued when the storm falls short of criteria for an advisory. These I use all the time in forensic meteorology because they are issued by the National Weather Service when there's confirmation that there's black ice on the ground or slippery conditions. And they'll say, hey, icy conditions are expected this morning. Temperatures are near freezing. Watch for residual surface moisture to refreeze. There have been some accidents reported. Okay. If you did not have an ice watch in effect, okay, or refreeze, and you see this product, get out to your site immediately because conditions are favorable for black ice or for any slush to refreeze into ice. You're going to have to get out there because it's already being confirmed by motor vehicle accidents or people slipping and falling. And the issue this is one of the best ways to know if you have to go to your site and do a refreeze check. Okay. Now, if you don't want to do all this work by yourself and say, Tommy, I'm tired. I work a full day. I don't want to, do this myself. I'm a parent. I work 2 jobs. Well, you can also hire a private forecasting company, okay, such as our company, WeatherWorks. All right. We have meteorologists on staff 24/7, 365 days a week. You tell us what areas you want us to forecast for, and we even customize the alerts for you. And we can actually send you forecasts, updates throughout the storm, send them right to your phone, to your email. You can even get the old-fashioned way, the fax. But you look at this alert pretty carefully, and you'll see that we give you a confidence in how much total snow is expected. The start time, usually a 3-hour interval, the end time. We also talk about melt and refreeze, okay? So there's 2 options. Again, you can use a National Weather Service, which is free. All right. The problem with the National Weather Service is you can't call them, okay, and ask them, hey, what's my forecast going to be? Or they're not going to call you and tell you, hey, you got to get to your site. Temperatures are below freezing. There's ice being reported. This is where a private forecasting company like WeatherWorks itself comes in and will tell you what's going to happen. Okay. The last topic I want to talk to you about, I get this question a lot, and I even have the judge ask me sometimes, and even a puzzled jury, okay? And the question is, can you get ice form on the ground surface when the air temperature is greater than 32 degrees Fahrenheit, okay? And the answer is absolutely, okay? And you might be asking me, well, how can you get water to refreeze or ice to form when the air temperature is above freezing? Well, it's not the air temperature you have to be concerned about, okay? The key is the pavement temperature, all right? Not the air temperature. In meteorology, the air temperature is measured at 4 to 6 feet above the ground surface, okay? The reason why it's at 4 to 6 feet above the ground surface is that's the average height of a human. They want humans to know what the temperature feels like, okay? But the most important key point is the pavement temperature. How do you take the pavement temperature? Well, there's a couple ways. You can have sensors that are installed in the pavement itself, or you can carry what's called an infrared temperature gun. You point that infrared temperature gun right at the surface. It will tell you what the temperature is. Similar to what we have right now during COVID-19. We have to go every time you go into a building, you have to get your temperature checked. Those are, similar sensors to that. Okay. But what I want to talk to you about is with the air temperature, how do you prepare for this? Okay. When do I know when the air temperature could be different from the pavement temperature? All right. Well, there are ideal conditions you have to look out for. Okay. So the ground surface could be several degrees colder than what the air temperature reflects, especially on the north side of a building or an area that is shaded from the sun. All right. Also, you have to watch out for even areas that are surrounded by residual snow. Like, let's say you have a sidewalk surface, you clear it, but on both sides there's snow piles. That snow acts like a colder area, and it's going to result in probably ice to form even with the air temperature above freezing. All right, but here's what I want you to look for. Okay, and there's ideal weather conditions you have to check, but basically the air temperature and pavement temperature could be several degrees different, usually near or shortly after sunrise. That's when the low temperature normally occurs. All right, ideal weather conditions you want to look for: clear sky, a long night, okay, light winds. Well, why the wind? Well, if it's pretty windy out, then the air is mixed very well, and you're not going to have too much of a difference. Solid snow cover. It's just like basically having the freezer open, okay? Best places to check: north side of the building. Why? Because they don't get any direct sunlight. Areas that are shaded from the sun, or locations that are surrounded by residual snow cover. And this also brings up a very important point too. Can ice and snow melt if the temperature, even the pavement temperature, stays below freezing during the daytime? And yes, it can. How? Because if you go outside and it's perfectly sunny out, any areas of snow or ice that are exposed to direct sunlight will melt. But as soon as it moves away from that direct sunlight, it's going to quickly refreeze into clear black ice. So something you have to keep an eye on. So there is no such thing as always in meteorology. Okay, air temperature above 35 or above freezing, we're not going to have any ice. Well, could. It's going to be in the single digits today. You're not going to have any melting. Well, if it's sunny, yes. So there's always conditions you have to keep an eye out. And I hopefully gave you some key pointers on the different types of ice: clear ice versus opaque ice, what you can do, different types of sources you can check, the National Weather Service or a private consulting company if you want to pay and not be in charge of always looking for it, like for WeatherWorks itself. All right. Well, I thank everyone for coming. Any additional questions, you can contact our forensic department at forensics@weatherworksinc.com, and we'll be happy to answer any of your questions. Thank you for joining me, and welcome to spring in a few days.